Okay, let's simplify some more. We want to evaluate these. Remember what we talked about. I want to know or see how you're using the rules that we're developing to simplify or evaluate expressions. So what I'm going to be doing for each of these is using those rules that we developed in the last page to simplify. Technically, you could use a fraction button and punch this in your calculator and it's going to spit out a number. I want to evaluate the rules though. So please show me the rules. So I'll do that here. So if I got 8 to the power of 4/3, I'm going to rewrite each of these as a radical. It's easier to simplify when they're written as a radical. So this could be 8, rewriting it into the exponent form first because I want to break up this 4 and 3. I don't have a rule really that represents the 4 and 3. It really is this 8 to the power of a third all to the power of 4. So we're going to rewrite it as in that form first, and now I can rewrite this as the cubed root of 8, and then that's all to the power of 4. And why I want to do that is because I can cube root the 8. I know from experience that the cube root of 8 is 2. So this is 2 all to the power of 4, and 2 to the power of 4 is 16. So 8 to the power of 4/3 is 16. Going back over here, we'll do the exact same setup. We'll rewrite this as negative 32, and then that's all to the power of 7. Rewriting as a radical, this is the 5th root of negative 32, and then that will all be to the power of 7. And now I'm thinking, what's the 5th root of negative 32? Something times something times something times something times something is negative 32. That something is negative 2. So that's negative 2 to the power of 7. And then I'll have to do that. Negative 2 times negative 2 to the power of 7 is negative 128. Okay. Last one here. We got to simplify this, but when you're simplifying this, have a look. I could crunch in 27 to the power of 4 in my calculator, and that's going to give me some large number. But then I can cube root. I could take the 6th root of that. That could give me some large number. But I could do this in a slightly different way. I could rewrite this as a fractional exponent and then see what happens, because 27 is a special number and 6 and 4 as a fraction is going to be a reducible fraction when I go to rewrite this. So going backwards in my rule, so the rule I'm using here is this b to the power of, or the nth root of b all to the power of, say, m is equal to b to the power of m over n. The n in the little pocket is the root, and it's always the denominator in the fraction. So this is 27 to the power of. Notice that's the 6 is all, the root is always the denominator. So this is the numerator. We've got 4 over 6. Reducing that fraction, we can say this is 27 to the power of 2 over 3. And now I can rewrite this as 27 to the power of a third, and then all squared. And I want to do that because I can do the cube root of 27, which we know is 3. So this is 3 squared, which is 9. So this expression turned out to be 9. Okay, next job. Do the little quiz after, do the survey, and you're done.